So yes, if you have any questions from the previous classes.
No.
So let's log in into Snowflake. Okay, so as I explained, sorry, worksheets are the main piece where we are going to work mainly. Okay, so let's go on the worksheets. You can create multiple worksheets. So this is my worksheets. Okay, you can add up the worksheets and you can give it proper name, like what you are trying to do on that particular worksheets. Let's say you say SQL worksheet. So now we have a SQL worksheet here. You can give it a name, like this is a name. You can edit this, maybe test SQL queries or something like this. You can name it as per your, as per your requirement. Then here right now I have a account admin role. So more or less you will get a role assigned by your security admins. You will definitely not have the account admin role. So you have to choose the role here. You can click on this. Whatever role is allocated to you, you can choose a role here. Okay. Once you choose a role, you have to choose a warehouse for your particular worksheet. I'll choose this warehouse for now. So then on my left hand side, you will find the databases that you have created or somebody else has created. Okay. Creation of the database is, again the same concept like we have in, normal SQL tools like SQL DB, MySQL, PostgreSQL, Oracle DB. Database is the same concept. Like here we have data space, schema, tables. So schema is a collection of tables. Database is a collection of schemas. More or less, its logical grouping is created on database labels. So either you can create a database via SQL query, or you can simply say, if I open this, you can simply say create database and provide a database name, and you are good to go. Not this one.
Jalad, can I ask one question, please?
Yes, sure.
Actually, I missed the yesterday part, and I am running two sessions behind from you actually in recordings. And can you just give me a context? This Snowflake part we have covered yesterday, right?
Yes, yesterday I just introduced this. So
Okay.
Snowflake is a data warehouse tool that we can use.
Okay.
It is right now in the competition with Redshift, Azure Synapse, Google's BigQuery. Okay, these are the four main data warehouses tools available in the market.
Okay.
It's mostly it is used for the analytical purpose. Mostly you will work with the SQL language here. So if you know SQL and if you go through these 3 or 4 classes, then you can very confidently say that you know Snowflake. Okay, you can add up this Snowflake in your tools in your resume. Okay. I hope you guys first. I mean, I should have asked this question yesterday only. I hope you guys are aware with the select statements, insert statement, like basic SQL queries, like group by, joins, some filters. I hope you are aware with those things.
Yes.
Karthik, for you?
Oh, yes, sir.
Okay. Yeah. So see, your SQL query, SQL syntaxes are not going to change. Okay. Only thing is changing here is, see, mostly on your previous databases, you are maybe writing the SQLs to update or insert or delete the rows mostly. Okay. Here you will write the SQL for mostly analytical part. You might be doing some kind of analysis. Okay. So that is a requirement you will get. See, majorly on the Snowflake, you will get some requirements like what I get right now. We have a data stage. Okay. We have a tool called data stage. That is pulling some data from some source, okay, converting those, doing some calculations, joins, or whatever, the logic was there to calculate the particular things. All those things we are converting into a SQL queries on Snowflake, scheduling them with the help of stored procedures and tasks in Snowflake. So this is how we are actually working on the Snowflake. Okay, so you might be using Snowflake to replace complete ETL pipeline like we are doing. You might be using Snowflake as a data warehousing tool. You might be doing your ETLs on AWS Glue and then pushing the data from AWS Glue to Snowflake. And then on Snowflake, you are writing only the queries which are analytical purpose. Okay, let's say you clean the data on AWS and then you create the analytical queries on Snowflake. This kind of project I was working with the previous client. Instead of Snowflake, those guys were having the Redshift server, not Snowflake, but idea or functionality is same only.
So in our case, what will be the data source? Is it Glue?
No, data can also be on Snowflake. So your raw data or your end data can also be on Snowflake.
So in our this part, we are creating the data itself, right?
Yes, in these examples, first I'm going to create data on Snowflake. I'm not going to teach you those insert and update statements. I'm more focused on the Snowflake Snowflake part, like the Snowflake features.
Yeah. So, but we will be inserting some sort of data in tables, dummy data or something.
Yes, that we are
Okay.
going.
Yeah. Okay.
How to upload data out of non-Snowflake directly, how to upload it from the cloud, that we are going to practice here.
Okay. So what will be the end goal of it? Snowflake integration with some sort of Glue or EMR we need to do, or is it something?
Not necessarily.
Okay, standalone.
This is what I'm. No, this is what I'm trying to say. In my current project, Snowflake is the standalone tool that I'm using for ETL as well. I'm using it for analytical purpose as well. Okay. So as I mentioned in the introduction also, Snowflake can help you solve various kind of tasks. So first of all, Snowflake is a third-party tool. Do not try to completely compare or accommodate it in the AWS environment. Okay. So you might or might not be using Snowflake in all AWS projects.
Okay.
This is a third-party tool. Why we are having this in our course? Because it is in competition with Redshift, okay, the AWS data warehouse tool, and this is much more efficient, or much more. You can say much more features are there in the Snowflake part actually.
Okay.
Snowflake can solve your data warehousing problems. It can solve your data lakes problems. It can solve your data engineering and data science problems.
Okay. So as you said, this is kind of you can say replacement or alternate for the Redshift, right?
Yes, it is alternate of a Redshift.
Okay. So anyway, we are going to cover Redshift also and the Snowflake also, right? Okay.
Yes.
Okay. I'm sorry, sir. Thank you for answering all the questions.
No worries. Okay. So you can select your database. I'm going to select GlueDB for now. And then you can choose the schema. So let's check in which schema I have the tables. In Glue schema I should have. Yeah, in Glue schema I have, yeah. So I'll choose the Glue schema. Okay. Then cancel this. So then I can, create, I can say, I should be able to preview data here. Size is there, definition is there. If I say load data, no, forget all this. So I can simply say place name is equal. Yes. Okay. So what I'll do, I'll simply say select star from this table. So you can see I am able to see my data coming with a SQL query. Okay. So how I've created this DB, you have, I think, two options, or let me duplicate this tab. Then you can come out of the worksheets. You can go in the admin. Sorry, you can go on the data. Here you can click on the plus on databases to create a database. Just type a database name. Let's say countries. You can provide comments. This is optional, and you can create this. It is as simple as that. Okay, it's like create database countries DB. If you want the SQL query to be executed, if you go inside this database, you can add a schema like this. You can say test. Okay, create this. It's like create a schema under DB. Okay, the SQL query will be like that. Once you have the schema created under the countries DB, you can go inside the countries test schema. You can create tables, views, stages. We will run about file formats, equals, pipe, statement, all those things you can create. So let's create a table, standard table. This is, you will get the create table statements created under this particular database. So I have one example here. So I will choose create table. Okay, I should have here Snowflake DDL. Yeah, this is the one that we want. I'll simply say create table. Okay, I'll come back on this one again. So here again, I mean, if you refresh this, you will get the other things also. Okay, in the earlier UI, we had the refresh button here. Looks like we need to completely refresh the page. So we have this countries DB. This time I'm going to change this schema to countries DB and test schema. Okay, I will apply my function, create table statement here. I'll call it countries. Okay. Now, if I execute this, it works. My table is created, but obviously this table does not have any data. So to verify this, select star from countries. If I run this query, you can see it does not produce any results. So how we upload the data? It's very simple. You can directly go on the countries DB table. Inside test schema, inside tables, countries DB, you can say load data. You can browse the file. I'll choose the file that I want to upload. I'll choose this file. Okay. I'll click on next. Then it's going to ask you some options. So my file is a delimited file. It is CSV only. Do your file have header? Yes, my file has one header. Skip first line, I'll say. Field delimiter, my file is delimited with comma only. Trim space, you can say true. It's your choice. Field optionally include by, yes, it is included by double quotes. And replace invalid characters if you want, if your file has a character that those are not supported by this DB, then you can replace those. If you want, you can do that. Date format you can select. So default is ISO date formats YYMMDD. So all those things you can select. I mean, basically it's like if your file has some date columns and in which format they are actually saved in your file, that you can define. In that case, the column will be treated as a date column. Time format, date format you can select as per your convenience. Okay. Then the last question is there. What should happen if the error is incurred while loading the file? You can choose do not load any data, or you can choose only load the valid data from file. Like you will skip the invalid rows and you will upload the rows which were correct, and you will ignore the rows which were not correct. In this option, no data will be actually uploaded. So again, your choice as per your requirement. Then if you click on show SQL, basically this is what you are saying. You are saying from this country's data set from your local machine. Okay. You're uploading the file and you're selecting various options like file format and on error and all those things. Okay. I'll hide this SQL. Let's click on load. So now we have successfully loaded 249 rows into this table. Okay. So if I execute this query now, you can see now I have the data in my table. So this is very basic way to upload the data into a Snowflake table. Create the table and upload the data into Snowflake table. Okay. This we have uploaded the CSV file. Now, if you see by default, it allows you to create some charts. If you know, if you are a BI person and you know how to create these charts and understand them, definitely you can do that part as well. Okay, so it does provide you some by default charts created automatically for the table, like bar charts, scatter plots, heat grade, scorecard, and all those things you can have here. You can choose your columns. You can add the column, and I mean, if you have the knowledge of BI, you can create some level of BI here only. Okay. Do not try to compare this with Power BI or Tableau or ClickSense. It is not a proper BI tool. It's just giving some glimpses of the data. So this is what it is. We can create table. We have uploaded data. Now, where this data got stored, as I mentioned yesterday, this data behind the scenes is stored on S3 object S3 machines. Sorry, S3 buckets, not machines. My bad. Okay. And if you log in into your AWS account, you will not be able to see in which bucket it is uploading your data, or or you will not be able to manage the data from your S3 service. Okay, you cannot log in into AWS in your account, and you cannot basically sorry, modify the data from AWS console. All the modifications, all the changes, all the queries you can only do from Snowflake console. Okay, and this is the reason why this table will be treated as a internal table or a normal table that you guys have seen till now, till date. Okay, if you do not know what an external table is, then you can say this is exactly the table that you have worked till now. Okay, so if you have any questions, let me know.
Jalaj, I have a question. Like, so you when you say it will be storing in nothing, so how will be uploading the data? So I mean, like a data processing. So it should also for data processing, also the data should be in S3 or from anywhere we can load it. Like, and how you load it now from desktop, right?
See, this I loaded from my computer. You can also load it from S3. That is correct.
Okay. So we have like location, right? If you say like for creating the table, right? We'll be specifying the location, right? So I can point it to my S3 bucket in AWS.
Yes, that will be your external table. But if you want to create an internal table, then you can obviously copy the data from S3 to Snowflake table as well.
Okay, so you'll be using the PySpark as some process.
No. There is a direct copy command that you can use. You just have to make some configurations, then you can use it.
Okay. Although you'll be creating views on top of the tables, like
yes,
like
more or less. Yes. Because we are not supposed to expose our tables directly to client, directly to consumers.
Okay.
I mean, it's a project specific, but mostly yes. So Snowflake does actually just because we are not a security person, but yeah, just to let you know, Snowflake does provide you row level security, schema level security. You can restrict the access to particular tables or particular schema or particular views. Okay, very high level, a very low level of customization actually you can make. Low level basically means you can go on very basic levels only. So all the customizations that you can think of, actually you can make most of those in Snowflake. Like I'm a developer, I'm working in some project, and I only want to access to only few tables inside this test schema. That also you can do, and also you can do only few rows also. That also you can do.
In real time also you're using the same thing, or you're using some other studio kind of thing to query or see the databases?
Mostly you will use this web browser only.
Web browser.
So is it some free tier or is something, or it's a completely paid service?
It's a paid service for the projects, but if you create a fresh account, you get $400 for first month.
Okay. And when you say we can upload the data from S3, they have given the provision to enter the access key or secret access key, then we can do, or do we need to write some custom script for it?
We will be creating a IAM role for this.
Okay. So we'll cover that scenario, right?
Yes, that I'm planning to cover actually.
Okay, thank you.
Okay, so see, till now whatever I've seen, this is quite normal to us. Okay, like creating the table, uploading data, and selecting the queries. One interesting thing in the Snowflake is its virtual warehouse thing. Okay, you can see I have a compute WS. This is a name given by me to a virtual warehouse. What a virtual warehouse basically means in Snowflake, it is a compute capacity that you have right now. Okay, basically you are renting a compute capacity on Snowflake. How this compute capacity works? It has. Okay, let's first of all understand what is virtual warehouse. Okay, virtual warehouse is the compute capacity that allows you to run your queries. Okay, so when I said select star from countries, like if I come here, no, let's come here. Cancel this and go in admin warehouses. It is started right now. Okay, what I'll do, I'll go inside this and I'll suspend this. Suspend. Okay, so if you see, if I refresh this page now, my compute warehouse is suspended. Is not now it is not now in green color. This basically means right now I am not paying any charges to Snowflake for compute level access. Okay. See, understand this part. Snowflake charges you based on two things. How much data you have stored on Snowflake. That is number one. Number two is how much compute capacity you use. Okay. So on Snowflake, the storage charges, sorry, on Snowflake, the storage and your compute are loosely coupled. Okay. Loosely coupled basically means they are independent from each other. Okay. This again means if you create 100 tables and you upload a 100 GB data onto those tables, you will only be charged for the storage cost unless you go ahead and create a warehouse and you run some queries using that warehouse. Okay, that basically means if you have 100 GB of data and you create a warehouse and you never execute any query and you never run that warehouse, you are not going to pay any money for that. Okay, why this is a very important, because on its competition like Redshift is a tightly coupled with storage and your compute service. Okay, when you launch a Redshift cluster, you get, if I give an example of the smallest node available on the Redshift, we get 160 GB of storage amount and obviously some 2 vCore CPUs for compute. What this means, if your Redshift server is running, whether you are running queries or not, okay, you are paying for the both compute and storage. Okay, that means your bills will be huge on Redshift. If you are like, even if you are using it or not, chances of having a high bills on Redshifts are more. That is one thing. One more thing is here, this virtual warehouse provide to you. Let's say the same 100 GB of data you might have in dev, you might have the same data in UAT and production as well. So On dev, you can create a virtual warehouse of small size, and you can allocate that to your developers to use that and practice, or I mean use that and do their development in the development region. Okay, that might be running the queries for 50 minutes, 30 minutes, like that, and you might be okay with that. Okay, some projects might not be, but some projects might be okay with that. Okay, but the same scenario we might not want on production. So on production, for the same storage, we can launch a bigger warehouse. Okay, so that that will solve the same data in less amount of time. That is one scenario when you have dev, UAT, and production. Let's consider one more scenario. So let's consider this scenario that in your project, mostly you run queries. Those are, those have simple logics that might finish in 5 to 10 minutes over some size of data, let's say 5 GB. Okay, but on weekends or on some rare occasions, you run very complex and huge queries. On that particular day, you can create a large warehouse. You can use that particular warehouse to execute the query, and you can get the results instead of hours into minutes. And you only paid for that particular amount of time that you use the large warehouse. So overall, the motive of this complete explanation is here the storage and cost, storage and compute are completely separated from each other. Okay, if you have high storage and low, I mean, these things are not dependent. Okay, like it will not say to you that now you have a 1 TB of storage, you have to run your query on a big web warehouse or like that. Okay, you can use this warehouses smartly and save some money here. Okay, I like for complex queries use big warehouse, for small queries use small warehouse. Okay, basically whatever we need we can use it. Again, repeating, virtual warehouse is something, it is a compute capacity that you can rent from Snowflake to calculate or execute your queries only for the specific time that you want it. Behind the scenes, okay, if you see this architecture here, behind the scenes on this virtual warehouses layer, what Snowflake is doing for you, it is launching EC2 engines, okay, from AWS side. Like if you are choosing the AWS cloud for your Snowflake account, it will be launching some EC2 machines behind the scenes. Okay, so if you have any questions, please let me know.
So Jalaj, compute warehousing is a kind of like will be defining like a vCOS, those kind of stuffs, right? So that will be defined by manual side or from it will be default kind of thing.
Sorry, come again with the question.
No, asking if you're creating this compute thing, right? So it's a kind of like how many vCOS, how many space, those things will be allocating a thing, or by like just like a serverless thing.
It's a kind of serverless thing for you. Just choose few options. Like let's take an example. Okay, you have to come on, like this is the landing page for your Snowflake. Okay, you will come on the warehouses, click on the warehouses and click on plus warehouse. Okay, I'll remove one of those warehouses. I mean, I don't want to create too many. First, let me remove one of those. Okay, now let's click on warehouse. You can choose a warehouse name. Let's say I say test WH. Okay, you can choose a type standard, or you have like standard warehouse can be used for most workloads, including Snowspark. Okay, then you have a Snowspark optimized warehouse after larger memory and the cache. So nowadays the Snowflake supports PySpark as well. This is what they are saying. This will support both SQL and the PySpark, and it is more optimized for the Snowspark kind of things. Let's choose standard one only. You can choose size here. X extra small, small, medium, large, X large, 2X large, and you can see it's charging you 512 credits per hour. And if I'm not wrong, 1 credit is equal to 4 US dollars. Let's actually search this. It might be because this number can change. Snowflake 1 credit cost $2 per hour. Okay, it's not 4, it's $2 per hour. And for enterprise edition, it is $3 per hour. And I think for business critical, it is $4 per hour, if I'm not wrong. You can choose, check this out. Yeah, for business critical, it's $4 per hour. So we guys are on. I'll choose you to. I'll ask you to choose enterprise edition because this one gives you all the features that you want to practice. For 30 days, we do get $400, so we are kind of covered. Yes, coming back here. Then you can go on advanced options. First one is auto resume. So as you can see, auto resume is nothing but like if you see, I have a query here. My warehouse is kind of suspended. If I execute this query, within a second, my warehouse will be active. Okay, it will give you the results and it will run the queries for you. So this one actually, this result actually we got from the cache memory because I had executed this query earlier as well. So if I modify my query slightly, where I can say where my region ID is 240. If I execute this query, you can see it's giving the results, and immediately you can see my warehouse is turned into a green color. This is what auto resume basically means. Obviously, then in that case we have auto suspend. So if you are not running queries for 5 minutes, it will automatically stop running. Okay, and it will avoid costing you some charges. I'll suggest you to use both of these and keep it to 5 minutes only and create the warehouse. As simple as that. So we have created the extra small warehouse. This is more than sufficient for our queries. Okay. If you want, definitely you can create large warehouse also. I mean, you do have $400. You can utilize that. So this is what we have. This is how we create warehouses, and it is creation is very easy. You have to understand the purpose of this. Okay. Purpose is basically if you're running small queries, use extra small. If you're running big queries and you want them to finish quickly, use big one. It gives you complete flexibility, how much you want to use and when you want to use, with what you want to use. All the flexibilities are there with you. So yes, if you have any questions. And obviously, definitely do not create this, very big ones. I mean, if you create this one 6x large, it's 500 into 3 for you on the enterprise edition. That means $1,500 per hour. Obviously, you have just $400, so please do not make such blunders. Okay. Until the large, I think we are fine. Okay. This also means $24 per hour. So until the large, I think we are fine. But try to use extra small only. This is more than sufficient for us.
Jalaj, also for regarding the job running time, right? So a job can run at any number of time, right? In like long running jobs are there, right? So it won't like Lambda functions, it will get truncated after 45 minutes, right? So like that, any limitations are there or?
No limitations on this. If your query is running, this warehouse will never get suspended.
No.
Okay, then let's move ahead. Okay, so I have already explained the architecture in the previous class. We will discuss more about this in maybe tomorrow or next after that. A few details I'll discuss more about the architecture. Okay. Now let's discuss tables. So Snowflake has three kind of tables. Okay. Temporary table. I mean, this is nothing a new concept. This is something we always have in the databases or data warehouses. Temporary tables. You use these tables for temporary storage. Okay. That basically means, let's say you are doing some calculations and in between there are some results like intermediary results you would like to place somewhere. Okay, for future reference you can create temporary tables for such kind of workloads, and as and when you log out from the Snowflake console, those tables will be deleted or discarded. Okay, let's say I create a temporary table here and I put the results of the select star from this you know like say put this let's try it out. Actually I haven't used it from quite a long time. Create, I can say temp. It's not like that. I'll get the syntax for you, but it's actually easy. Just you see, just to say create temporary table. You can clone the main table, and then you can put the table results into that table, and you can use the results further in your queries. As in when you log out from this console, those tables will be deleted. So those are useful only when you're doing some testing, some debugging. Only in those cases those are useful. Because if you create a normal table, then if you give some random names to those tables, and if you create normal tables, those tables will persist. They will cost you first of all, and also if you check your DBs, you will find too many unnecessary tables created for just because you are doing some debugging. Okay, so in those scenarios, recommendation is to use temporary tables. Then we have transient tables. Snowflake supports these transient tables that persist until explicitly dropped and are available to all users with appropriate privileges. Only difference with a normal table or a permanent table in the transient table is that they do not have a fail-safe period. So fail-safe period is nothing but in Snowflake. Let's say I have this table. Okay. Let's say I have this table. Create. Let's say I have this countries table, and I just say, let's say I have some very new developer, and he does this delete from countries. Let's see, he does this part. Okay. I deleted all the rows from my table by mistake. Then Snowflake has a fail-safe functionality that basically allows you to retrieve back the results from the table, even though you have deleted those. So it actually creates the layers. Okay, I'll say it creates the layers. So this is the action that you did on your table. This action is actually implemented, but in behind the scenes, it also has the previous copy of your table. So if I have the syntax with me, yeah, you can write something like this. I just deleted the data from my table, and then this is actually time travel. This is not a fail-safe example. This is example of time travel. I mean, there's no huge difference between time travel and the fail-safe. Functionality is a kind of same thing, only to recover the data from your unwanted commits that you make on your table. So right now I'm saying I want the data where my I want the data when my country's table was today is Wednesday. Date is 6th of December 2023, and I'm not sure what time zone it is working. Let's try with Indian time zone only. So I will say 20, let's say 43. And if I execute this query, my table, no, it should be countries. This query, my timestamp function that needs to be constant found cast. Okay, looks like some syntax issue, but there's more way to do it. Offset variable, I mean, this is more easy than this, modifying this. Just use my countries table first of all. At offset minus 60 into 5, whatever the state was there 5 minutes before. If you do this, you can see I'm still able to get all the queries from, all the data from my table 5 minutes back. Okay. If I do insert, why it is not working like that? I'll say insert into, then I will say my table name. Like this, I can, fix my table again. If I remove this delete and if I run this query again, I'll get the data again. So this is a feature of Snowflake. This is called time travel. There's a slight difference between failsafe and time travel. That is, which actually I'm not able to recall right now. My bad. I'll get it for you. But this is the example that I've shown you. It is an example of time travel. So time travel is a feature of Snowflake. Okay. That allows you to pinpoint your table on a specific time. You can say, okay, I have made a mesh of my table, but I want my table what it was 7 days back or 8 days back or yesterday or day before 3 days back or like that. Okay, I mean you can be precise to a second as well. Okay, but time travel costs you. Okay, time travel costs you when you create the table. By default, if I'm not wrong, it stored or it allows the time travel for 7 days, and you can make it up to, I think, up to 90 days. You can mark it up. What happens in the time travel? Snowflake creates the layers. Okay. By layers, let me explain it to you. I'll try my best to explain you the layers. Let's say I have commit 1. I have commit 1. Okay. Here I have 430 rows. Then I did some commit 2 at some time. Forget about the time. Okay. I have 530 rows. Why I am having strike through, where is it? Okay, forget about that part. Let's remove the tail link. Okay. Then I might have then I might have commit 3. I might have 490 rows. Okay. So on all these commits, Snowflake is also going to maintain, the changes. Okay, this is the original state of the table that is present right now on commit 2. That is okay. But what is the difference between the commit 2 and commit 1? Snowflake is also going to take the note of that. And when you say I want commit 1, it's going to discard the changes that it has done in the commit 2. This is how it actually works in the time travel. Okay, so let's say your latest commit is commit 3, where you have 490 rows, 40 rows less than commit 2. Snowflake will know the difference between commit 2 and commit 3 is 40 rows being deleted. So when you apply the time, or when you supply the time, or in your recovery query, Snowflake is going to identify, okay, 4 hours back we had a second commit, and in that commit there were 40 more rows available in the tables, and it's going to give the results from that particular commit, not from the commit 3. When you go back on commit 1, it's going to discard 2 changes. Okay, so basically you can say it keeps a track of changes, and when you try to go back in the time, it discards those changes. For maintaining these changes, okay, if you maintain these changes for 3 months, obviously it will need some more storage, and for that you will have to pay. So obviously for productions, you might want this. You might want this, time travel period to be enabled for sure. In dev, definitely you might not have this feature, or even if you have, you might have it for 1 or 2 days or like 3 days. That's all. So I hope I was able to explain you the time travel feature, how it works actually. I mean, it is actually very easy, but how it actually works, this is something we need to understand. So let me know if you have any questions.
I'm good as of now.
And also let me know if you have any questions on these tables. Pardon me for this mistake. I should have gone through this fail safe and time travel difference. It's not huge. It's just one simple thing. But this is also, to recover your tables from unfortunate queries.
Jalat, I have a doubt. Since you said the tables are going to store in S3, right? So we can't update the data, right?
Manually we can't, but Snowflake can.
Oh, Snowflake you can. Okay. I'm asking because telling about commit, right? So generally we want to give the commit, pass the commit manually, or
No.
like
I'm
next
just using commit word because it is something very known to you. Yes.
Okay. So update option is available in Snowflake, right?
Yes. I mean, see, all the things that you can do in your databases, you can do in your data warehouses already. Okay. Forget about the Snowflake. You can do in Redshift, BigQueries, Azure Sims, or everywhere. Only thing is that these things are not built for your OLTP. These are built for OLPs. And one more interesting fact you will find, these tables does not support primary keys, foreign keys, those relationships. You cannot create primary keys. You can indicate a column to be primary key. Okay. I mean, I'm not sure about the Snowflake, but I'm definitely sure about the Redshift. You can indicate this column to be primary key, but if you put a data where you have duplicates, it will accept that. It is just for your understanding that this column is primary key. I have to treat this column as a primary key. It is just for your developers. Okay. But the table is not going to reject the rows based on duplicates like your databases does. These things are purely built for analytical purpose. If you try to use them for OLTPs, it will work. I mean, understand this part. You might use a cricket bat for playing baseball, but it does not, it is not built for that. You might play a cricket game with hockey stick, but it is not built for that. The same way, data warehouses can do OLTPs. You can do row level updates, inserts, or deletes, but these things are not built for that purpose. These are built for batch. These are built for bulk updates, bulk inserts, and more or less they expect you to run analytical queries, okay, where you want to analyze your data. So yes, if you have any questions, you can let me know. Otherwise, tomorrow I'm going to plan a few interesting demos, where first of all we will try to load a CSV file from our S3 buckets to tables inside the Snowflake. Then we will try to upload a Parquet file, and in that process we will learn the stages, file formats, and all those things into our Snowflake tables. We will learn about the Snowpipe functionality. Okay. Then we will see what is the micro partitions in the Snowflake, and we will also see how we can create a Snowflake from the AWS Glue.
Okay. Jalit, I have one question, a generic question, not related to this one, Snowflake. Actually, I'm new to all these things. My background is something from the .NET and all. So, should I we have PySpark and all these things. How much should I need to devote time on this Python and all for this data analytics part for the longer term? I'm asking, not for this one.
See, I'll say first, first thing, improve your SQL.
Okay.
Okay, you will be tested on SQL for sure in the interviews. If the interviews is completely not in mood, that is, you will be very lucky if he doesn't ask you any SQL queries to be right. For sure, he will test you on the SQL because he knows you have to work on Redshift, you have to work on Snowflake, and as I shown you yesterday in the study class, we have seen we can use SQL in PySpark as well. So we can completely ignore the PySpark syntaxes and we can simply use a SQL as well.
Okay.
Okay. So first thing, major thing is SQL. Second thing is learn PySpark. You might not learn PySpark. I mean, see, syntax wise, whatever I have shown you now, that is more than enough. Okay. Syntax wise, that is more than enough. Just do some practice on over that. So if somebody asks you to write a join in PySpark, you should be able to do that.
Okay. So PySpark is based on you can say Python, right?
No. I think see,
Okay.
Spark is an engine and
Okay.
framework. Okay, Apache Spark is a engine and a framework that has some compute capacity and that has some libraries to solve your data problems. Now Spark can be utilized with Python and Scala. By default, you always remember by default is Scala, not Python.
Okay.
Okay, when you install a Spark and when you launch the Spark, see, if you, I am not sure if I have the install a Spark with me right now. But if I have it, if I type this Spark will launch its machines in with Scala. It will not launch with the Python. Okay, so default is Scala, not Python. But Python is the one which is mostly in the use because Python is the programming language that everyone is running towards, and everyone is trying to learn Python, not Scala. Yes, you do have jobs. Yes, you do have jobs with Scala as well, but not as many as the Python. Okay.
Okay.
Third thing is you will very rarely use the normal Python to do any data engineering. Okay. That is also there. Just simply using the Python is not going to help. With very obvious reasons, because as I told you, Sparks can handle huge data sets. Python can also do that, but you will need more optimization and still it will not be able to match the level of Spark. Okay. And nowadays, if something is growing in these days, that is data. Okay. Every day, every minute, a new data is being generated for every other client, be it like let's just assume let's say you are working for a web online website company or online, what we call this, online marketplaces, let's say Swiggy, Zomato or something like that. Every day millions or billions of orders are being placed. That means some 5 to 10 GB of data is being generated around. I'm saying very rough numbers. Okay, I'm not trying to guess the correct number. I'm just saying very rough numbers. 5 to 10 GB of data is being generated every day. If something that is growing, that is data is growing, one day you will find that Spark is also not able to match or do analytics over the data. You will still have to improve your hardwares. One more thing. These all data engineering, data analytics, machine learning, data science are not new concepts. Okay, you will find the books on regression, classifications, data analytics. Over these topics, you will find the books from 1950s, 1960s. But over that period of time, we did not have the hardware to match or write those algorithms or write those programs. Today we have the hardware. That's why we are writing it. Okay, so that's what I'm trying to say. I think we have moved past the level of Python. Python you should know. Okay. Even in the PySpark code, we might use Python very smartly. So if you see one example, if I show you the final project code, this is the project that we are going to work in the last. Okay, if you see, even though I have a Spark code, but sometimes I do use Python to do some testings here. Some work
Okay.
I'm still in Python only.
Okay.
Native Python, you can say it's not very heavily used in the data engineering project because data is huge. We do need some SQL server, some warehouses, some analytics, some Spark capabilities. That's why Spark is a very mandatory thing. And see, when you go in the interviews for Spark, they might not ask you to write any Spark syntax, or they might not even talk about those Spark syntaxes. For sure, they are going to talk about Spark optimization and Spark architecture. You need to kind of memorize those things. Whatever we discussed in the last Spark class, the part 2, where we learned about the number of jobs, number of stages, number of partitions. One more thing is there, broadcast variable, that I'll talk when we learn about the Redshift. What is the narrow transformations, what is the wide transformations, what is DAG, what is lazy evaluation in the Spark, what is worker nodes, what is executors in the Spark, what is the Spark context. These are the things you should, they should be memorized to you.
Okay, thank you. Thank you very much, Jalaj.
Yes, Karthik, Mr. Vidya, you have any questions?
No, Jalaj.
Okay, in that case, we'll wrap it up here. Tomorrow we are going to do some interesting hands-ons, so please be available. And till then, it's goodbye. Thank you, guys.